maxima and minima. Let f be a function defined on an interval I. Then f is said to have a maximum value in I if there exists a point C in I such that f of x less than or equal to f of c for every x belongs to I. That means in the interval, if you take any real number in the interval, f of x, value of f of x less than or equal to f of c. So c is a point in the interval I. Then for every x belongs to the interval, f of x will be less than or equal to f of c. So this number, this f of c, that is called the maximum value of the function. F of c is called, this is called maximum value of the function. Because for every real number x in the interval I, f of x is less than or equal to f of c. So f of c is the maximum value of the function in the interval I. And c is that number c. C is the point of maximum value. Similarly, f is said to have a minimum value in I if there exists a point C in I such that f of x greater than or equal to f of c. This is the minimum value. F of c is called minimum if for every x belongs to I, f of x is greater than or equal to that f of c. So f of c is called minimum value if f of x greater than or equal to f of c for every x belongs to I. If f of x less than or equal to f of c for every x belongs to I, then f of c is the maximum value. So here f of c is maximum value, here f of c is minimum value. Because for any value of x, f of x is greater than or equal to that number here. Here f of x is less than or equal to that number, f of c. So here f of c is maximum value, here f of c is the minimum value. And if f of c is either maximum or minimum, that is called extreme value. F of c is called extreme. So if it is either maximum or minimum, it is called extreme value. Now we will do some example. Now consider the function f of x equal to x square. Consider the function f of x equal to x square. For every x belongs to R. Here domain is set of all real numbers. Now we can find the maximum value or minimum value. If the function has any maximum value or minimum value, we can find out. See, we know x square, here x belongs to R. X is any real number. We know that x square is greater than or equal to 0. For every x belongs to R. We know x square is greater than or equal to 0 for every real number x. That we know that. We know. Now x square. So what is x square? X square is same as f of x. So f of x is greater than or equal to 0 for every x belongs to R. So f of x is always greater than or equal to 0. That means this 0. 0 is the minimum value of the function. Because for every x belongs to R, f of x is greater than or equal to 0. So 0 is the minimum value of the function. And what is the point of minimum value? Because this 0, when we get f of x equal to 0, f of x is equal to 0 when x equal to 0. When x equal to 0, when x equal to 0, f of x equal to x square is 0. So this 0, we can write in the place of 0, we can write f of x greater than or equal to f of 0. Because when x equal to 0, f of 0, when x equal to 0, f of 0. That means value of the function f of x when x equal to 0. So we know f of 0 equal to 0. Because when x equal to 0, f of x equal to 0. That means f of 0 equal to 0. So in the place of 0, we can write f of 0. So here we get f of x greater than or equal to f of 0 for every x belongs to R. For every x belongs to R. So f of 0, what is f of 0? That is 0. 0 is the minimum value. 0 is the minimum value. 0 is the minimum value of the function, and that minimum value occurs when x equal to 0. So that x equal to 0 is the point. Is the point of minimum value. Point of minimum value. So f of 0 is the value, minimum value of the function, and x equal to that occurs when x equal to 0. So x equal to 0 is the point of minimum value. Now we know the graph of this function y equal to x square, that is parabola. From the graph also we can understand. We know x square equal to y is the graph. Graph of x square equal to y is this one. And this is origin. And we know this origin at x equal to 0, function has minimum value. Here the function has minimum value and it increases. It can be extended to any length here. This goes on like this. So there is no maximum value, but minimum value of the function occurs when x equal to 0, and when x equal to 0, y is also 0. So f of 0, when x equal to 0, f of x equal to 0. So f of 0, that is 0, is the minimum value of the function, and minimum value occurs when x equal to 0. So that is the graph of the function f of x equal to x square. Similarly, we can draw the graph of f of x equal to modulus x. From the graph also we can understand. So graph of modulus x is this one. This is the graph of modulus x. Here also minimum value occurs at the point 0, 0. So 0 is the minimum value of the function f of x equal to modulus x. And there is no maximum value. It increases indefinitely. No maximum value, but minimum value is x equal occurs when x equal to 0. So x equal to 0 is the point of minimum value, and minimum value of the function is f of 0, that is equal to 0. See, where f of x equal to modulus x. This is the function. When x equal to 0, that is value of the function is called f of 0. That is modulus 0, that is equal to 0. So when x equal to 0, value of the function is 0. So minimum value of the function, this is f of 0 is the minimum value, and x equal to 0 is the point of minimum value. That is the difference. Minimum value of the function is f of 0. Point of minimum value is x equal to 0. So these are the examples. Now at 6.5, first question, we have to find the maximum or minimum value of the function if it exists. See here, first one, f of x equal to 2x minus 1 whole square plus 3. This is the function given. We have to find whether the function has any maximum value or minimum value. We have to find that. So we know square of 2x minus 1 whole square, we know that perfect square. Square of a number is always greater than or equal to 0. That we know. So using that, we can find the maximum or maximum and minimum value of the function. So first we can write 2x minus 1 whole square. We know about 2x minus 1 whole square. And here also x is any real number. So here 2x minus, if x is any real number, 2x minus 1 whole square is greater than or equal to 0. For every real number x, 2x minus 1 whole square is greater than or equal to 0. Now we want to know about the function. Which is the function? 2x minus 1 whole square plus 3. So with this, in this inequality, we can add plus 3 both sides, because we want 2x minus 1 whole square plus 3. So we can add 3 in this inequality both sides. So what we get? 2x minus 1 whole square plus 3 greater than or equal to 0 plus 3. We add 3 both sides. So here the left side is the function f of x. So in the place of 2x minus 1 whole square plus 3, that is same as f of x. So here we can write f of x. And we got f of x is greater than or equal to 3. So f of x is greater than or equal to 3. Therefore, that means 3 is the minimum value of the function. For every real number x, this is true for every x belongs to R. So for all real numbers x, f of x, value of the function, is greater than or equal to 3. So for all x, it is greater than or equal to 3 means 3 is the minimum value. For every x, f of x is greater than that, greater than or equal to that. So 3 is the minimum value of the function. And here we want to find only the minimum value, and if the question is the point, to find the point at which function is minimum, then we have to find the value of x when f of x equal to 3. So this is the function f of x. This function f of x is equal to 3 when this is 0. This is 0 means x equal to 1 by 2. 2 into 1 by 2, 1 minus 1, 0 square. So this 3 occurs when x equal to 1 by 2. When x equal to 1 by 2, f of x equal to 1 by 2. 2 into 1 by 2, 1 minus 1, 0 square, 0. 0 plus 3, 3. So this here 3 is the minimum value of the function and x equal to half is the point of minimum value. That is the difference. Point of minimum value and minimum value. Here 3 is the, so here only we want to write which is the minimum value. So we can write therefore 3 is the minimum value of the function. 3 is the minimum value of the function of f. And x equal to half is the point of minimum value. That is the answer. Now see the second question. Second one, the function f of x is equal to 9x square, 9x square plus 12x plus 2. 9x square plus 12x plus 2. Now here we want to find the, so if you write in the form of perfect square, it is easy to write. We know perfect square greater than or equal to 0. So we can use that. So here we know 9x square is same as 3x whole square. And 12x is what? 2 into 3x into what? 2 into 3x, 6x. Here we want a square plus 2ab. So what should we be to get 12x into 2? So 2 into 3 into 2, that is 2 into 6, 12x. So this term is 3x whole square. This is 2 into 3x into 2. So to make it a perfect square, a square plus 2ab plus b square. So 2 square we want to add to make it a perfect square. So we can add plus 4 and minus 4. Then we can write this plus 2. So we can write this as 3x whole square plus 2 into 3x into 2 plus 2 square. So this is a perfect square. Then minus 4 plus 2 minus 2. That is equal to 3x plus 2 whole square. So this is same as 3x plus 2 whole square. 3x whole square plus 2 into 3x into 2 plus 2 square. So this is the perfect square. Then minus 4 plus 2 minus 2. So this is same as 3x plus 2 whole square minus 2. Now we can write, we know 3x plus 2 whole square is greater than or equal to 0. We want plus minus 2. So we can add minus 2 both sides. So 3x plus 2 whole square minus 2 greater than or equal to 0 minus 2. So we get, this is same as f of x. F of x greater than or equal to minus 2. So that means minus 2 is the minimum value of the function. And there is no maximum value. Minimum value is minus 2. So like that we can find the minimum value of the function. Now next we can, third question. Okay, we'll continue in the next session.